Okay, ladies and gentlemen, we are now about to embark on the final panel for today, and quite an interesting topic. If anyone's on the outside there wants to come in, we've got some seats out here and on this side, so please make your way in, and we'll get started. It's my great pleasure now to introduce the moderator for today's panel on marine mining in the Red Sea. It's Dr. Zaher Nawab, President of the Saudi Marine Mining Company. Thank you.
Voice. بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين. On behalf of myself, and on behalf of my colleagues, we welcome you all in this panel. When we talk about mining, more than 90% of the people, they think about land mining. Lands compose only 28% of the globe. And all what we extracted from the land until now, it is only from 28% of the globe. The other 72%, it is the ocean. And our topic will be strange or peculiar for many people. They don't think about ocean mining. So I will introduce my colleagues to talk about the Red Sea and the ocean and the mining from the Red Sea, and each one of them will introduce himself properly and talk about the subject. I will start with Dr. Abdullah Dabbagh. Please.
Thank you. I'm Abdullah Dabbagh. I'm a director of marine mining. I have been involved in other mining activities before in Saudi Arabia, and the government has had very ambitious plan to increase the mining activity in Saudi Arabia. Therefore, between 2016 and 2018, we got involved into building a strategy for mining in Saudi Arabia, which is being implemented today. Further ambition came, and we started thinking about marine mining. Marine mining may sound unusual to a lot of people, but I want to make it simple and give an idea of what we're trying to do. The Red Sea is actually opening the surface of the crust, making a huge trough in the middle, and in that trough, from the mantle, solutions are coming and depositing at the bottom of the sea in what is called pools. These pools has been known since 1947 when they were discovered first. And then in 1975, the Saudi Sudanese Commission with PRUSAG came and had been supported by financing from Saudi Arabia to study these pools. These pools actually are about 2,000 meters below the sea level. With the solutions coming, depositing sulfides, and salts are covering the sulfide. It's not unusual in most seas when you have a drift that happens. But what happens in particular in the Gulf, in the Red Sea, is that these pools are too deep and they have the salt holding all the solutions that come and form a sediment layer, sulfide sedimentation. Now, how can you get down to 2,000 meters? They did it in 1975, and he was in charge of the activity. They brought out the minerals, which is very fine mud containing copper, lead, zinc, silver, nickel, cobalt, and it was difficult and a challenge to process it, but they were able to find the best processing methodology, and they produced metals. Now, at that time, the value of these minerals was very different from what the situation is today. That's why we're going back to the same locations, and here we formed marine mining in Saudi Arabia, and we created a group of alliance from 24 German companies who have the technology and the ability and have experience to work in deep seas all around the world. And we intend to explore and mine these deposits. It's unfortunate that there are I can't show any pictures, but this has been done in a mining trial in 1985, and we intend to do it within the next few years. We have applied for 5 licenses, and the process is going on.
Thank you, Dr. Abdallah. These sediments and deposits to be mined and to be brought to the surface, it needs special tools and technologies. And we will listen to engineer Leo to tell us about these tools and technology developed for deep sea mining. Please.
Thank you, Dr. Sawyer. Yes, my name is Leo Weixler. I'm managing director of the company Seabed Mineral Services, which is a joint venture between the shipping company Harn, German shipping company, and a specialist foundation and exploration equipment manufacturer Bauer. And we have formed this joint venture to develop technologies and equipment, especially for the exploration and later on for the mining of seabed minerals. And as Dr. Abdallah mentioned before, we have this association in Germany, the Deep Sea Mining Alliance. I am very proud to be the president of this alliance. When we talk about technology, we need to talk about technical risk and also sustainability. We heard that this exploration was done already 40 years ago, where I was before the beginning of my career. So that means the basics have been set already at this time. Since that time, many things have changed. We would say sustainability comes first, electrification comes first, and therefore we have developed in the last years in this joint venture several technologies and methods to explore such deposits like these muds or massive sulfides. And when we are doing this, we do not want to invent everything complete new. We are looking back what we have already done so far, and that means we can work with sophisticated technologies and offshore operation vessels from Harn, and also with exploration equipment which was developed by Bauer Maschinen and which was already is already used since 15 years. We have a track record for exploration rigs with several research institutes who are using this equipment up to a water depth of 2,500 meters. So for us, 2,000 meters is not a big challenge anymore. And also for these special mud deposits, we have developed a method, we call it the vertical approach, which can mine very precisely such three-dimensional mines. This technology is coming from the foundation industry, where we also have a long track record. So it means we wanted, when we develop such new technologies, we are creative, but we are creative in this way that we reduce the risk as much as possible, and we also can look on the things which have been done 40 years ago. But as time has changed, for sure, we need to make this technology at the latest state of the art to save energy, to electrify it, and as the other speakers have told, to make a digital twin to operate it as smooth and as environment friendly as possible.
Thank you, Engineer Leo, for that. And the development and mining in the Red Sea or any other place, it needs a lot of environmental studies. And in the Red Sea, beside the environmental studies, we should also do some oceanography to know the ocean and the currents and waves. So Dr. Johansen and Professor Andrea will tell us about the environmental effort has been done in such cases. Please.
So I may start because I will talk about the old times. I am one of the fossils from that time. From 40 years ago, I was working in the Red Sea on this project, and that was the reason I'm physical oceanographer. I got this job because as a physical oceanographer, I was specialized on environment, and so at that time, you may be very amazed, at that time in 1976, we already started with huge environmental investigations, which at that time nobody was thinking about environment, but the Saudis asked us to take care about the Red Sea and about the environment within the Red Sea. You know, there are a lot of coral reefs. It's a very beautiful area, and mining at that time, of course, was always a little bit dirty. So we were looking about what could happen when we were, what was the goal at least later on, what could happen when we were mining and what is about the tailings. So we did a lot of exploration work. That means we did 3 huge surveys concentrating on the whole environment to learn more about that. And even we did computer simulation models. We did current measurements. We followed the tailings, which was pumped up from the Red Sea and then from the bottom and then down back into the deep ocean. And so we followed that with the traces, very modern method, and could see where the traces are then where the sediment is going down. So this and a lot of many different other things like geochemistry, biology, everything which is important for the environmental system of the Red Sea was investigated from us. And at that time, we could say the system, how we did use it and how we develop it was good enough for producing these resources.
Andrea.
Yes, please, can Professor Andrea comment on that? Yes. Please.
Yes.
Professor
Thank
Andrea,
you. Good afternoon.
Okay, please.
Yeah. Thank you. Yeah, good afternoon from Bremen, northern Germany. My name is Andrea Kuczynski, and I'm working as a professor of geosciences at the Constructor University Bremen, formerly known as Jacobs University Bremen, which is a private international English-speaking university. And my field of research is marine geochemistry, with a focus on trace metals, both as resources and also with respect to environmental aspects. And I've been working on marine minerals such as ferromanganese nodules, crusts, and hydrothermal vent fields for about 30 years. And my first investigations of the environmental impact of deep sea mining date back to the early Discol experiments, where manganese nodule mining was mimicked in the Peru Basin in the Pacific, and was monitored for a couple of years. And then there was a longer pause, and these investigations were resumed in 2015 as part of the European JPI Oceans Mining Impact Project in the Peru Basin, where we now have a 30-year-long record, and in the Clarion-Clipperton Zone in the Central Pacific, where most nodule exploration licenses have been issued by the International Seabed Authority. And my role in this project is the potential release of toxic trace metals and supporting the development of threshold values and of environmental guidelines. We can say we have really learned a lot on short and medium-term environmental impacts of deep sea mining in this project, such as influence factors, recovery rates of the ecosystem. And part of this knowledge will be applicable to mining metalliferous mud in the Red Sea. For example, the new insights that we got from particle plumes that are created by the sediment suspension. However, we have to keep in mind the Red Sea is a very unique place with very special and partly also rather extreme conditions, which means that there will also be differences in physical, chemical, and biological reactions on a technical disturbance compared to other open ocean regions. Much information has already been gained by the earlier project, as Johannes Post just outlined. However, accelerating climate change, industrial activities, and fishing may have modified the situation in the past decades. And so, to start with this, a thorough survey of the present situation would be really required to create a baseline data set. And we need this baseline data set to identify deviations that may be caused by mining activities. Critical threshold values and environmental guidelines need to be defined based on expected negative consequences of mining when certain limits are crossed. And here, biological species, trace metals, and nutrients in the water column will play a very important role. But it will be practically impossible to examine each species and each metal during future monitoring. And so we need to identify key species and parameters that are representative of the health of the ecosystem and that we can use for the monitoring approach later on. But in addition to looking at the environmental impact in the sea, on the sea floor and in the water column, a holistic consideration of such future mining operations would be desirable, especially in the light of the global biodiversity crisis, the climate crisis, and the need for sustainable development. And here the right technology, as Leo Weixler already pointed it out, will play a very important role. But also greenhouse gas emissions generally, the carbon footprint is an important story. Calculations of greenhouse gas emissions in manganese nodule mining operations due to the technical equipment and the mining ships have shown that these emissions can easily get into a similar order of magnitude like in land-based mining. However, I believe that for the Red Sea, because of the relative proximity of the mining areas to the ports, this will be likely a lesser factor. Metallurgical processing of the Red Sea ore on land would create about the same environmental footprint like the processing of land-based sulfide ores. And here, a zero waste process and product would be desirable to avoid any environmental harm because of mine waste dumping. A really big advantage of deep sea mining is, compared to land-based mining, that all equipment will be reusable and no mining infrastructure will be left behind or abandoned on the seafloor. Considering that metal mining on land often destroys very valuable ecosystems with high biodiversity and high carbon storage capacity, such as wetlands and rainforests, mining the seafloor could here even be more sustainable, as the biomass in the Red Sea appears to be comparatively low and no significant release of carbon from the seafloor due to the mining activities is to be expected. Nevertheless, also due to its uniqueness, the Red Sea ecosystem clearly deserves a precautionary approach of deep sea mining development with the ultimate care to minimize the potential environmental harm. Thank you.
Thank you. Thank you. Lately, King Abdulaziz City for Science and Technology established a Marine Center. And we have with us Dr. Hisham Shugair, and he will tell us about the ambitious and the project of this new center. Please.
Thank you. Thank you so much, Dr. Zaher. I'm honored to be part of such a distinguished panel. So first, I'd like to introduce myself. My name is Dr. Hisham Shugair, and like Dr. Zaher just mentioned, I'm here representing the King Abdulaziz City for Science and Technology. We like to consider ourselves one of Saudi Arabia's premier national labs. We have multiple research institutes underneath our establishment, Recently, we launched what we're calling the Deep Sea Exploration R&D Institute. Underneath this institute, we found much alignment with much of the activities that are being done in marine mining. So we look forward to national programs and projects that inspire our research team to develop new technologies for marine mining, looking in for ways to consider the environmental conservation, sustainability. To give you some examples of some of the technologies we currently have, we currently possess a research vessel. It's being used for environmental conservation activities. We also possess underwater drones that we're looking for ways to explore different use cases for marine mining. Some of the technologies we've seen from the panel members are advanced technologies, recent advancements we've seen over the past few years. So we look for ways to cooperate within the kingdom in terms of transfer of know-how, transfer of these technologies, as well as localization of our existing capabilities and national priorities. As part of a recent announcement over the past summer, the national RDI priorities within the kingdom, underneath which we had unlocking unexplored deep sea for scientific and entrepreneurial usage. So this statement alone gives our institute enough vision and enough motivation to look for simple ideas from basic science to advanced topics like what we're talking about today in marine mining. Thank you very much.
Thank you, Dr. Hisham. And now, excuse me to tell you a little bit about Atlantis 2 Deep. Many people, they don't know what is Atlantis 2 Deep and where it is. Atlantis 2 Deep, it is in the axial trough of the Red Sea between Saudi Arabia and Sudan. Neither one of them can exploit Atlantis 2 alone because it is now belong to two countries and being approved by the United Nations. So Saudi Arabia and Sudan in 1974 signed an agreement to establish the Saudi-Sudanese Red Sea Joint Commission for exploitation of the sediments from the bottom of the Red Sea. In 1975, started the programs with marine oceanography and with environmental studies. In 1976 and 77 and 78, we start doing the pre-pilot mining test, where we were successful on pumping the slurry and the mud from a depth of 2,200 meters up to the surface of the vessel, and we did the flotation using seawater, and then we made a concentrate, and from that concentrate, we were able to bring real metals, copper, zinc, lead, gold, and silver, and it being submitted to the two governments officially. The project was frozen at that time because of the funding. Now, it is open again, and our coalition group, inshallah, also with CACS, we will apply for the Atlantis 2 Deep, and we have a very ambitious program. It is located almost about 200 kilometers west of Jeddah and about 190 kilometers east of Port Sudan. And this will be a very good example of the cooperation between two countries facing this project. Is anyone of my colleagues has anything to add?
Yes.
Please.
I think a lot of people, when you talk about deep sea mining, they can't perceive the idea very well. But here is a case in which in 1980, the sediments were pulled to the surface of the ship. It was separated, metal was formed and given to the States. With today's technology, we should be a lot further. One other issue that took place at that time is there was an estimate of the amount of different metals that are available, and not all the metals, only the 4 that we have mentioned. the value of that was estimated at the time. At that time, I was in King Fahd University of Petroleum and Minerals, and we did the estimate, the economic study for the commission. But after our evaluation, it was redone again in 2008 and 2014. The last estimate in 2014 says that the value of the metals in one of these pools is between $10 to $13 billion. That's a huge amount. And the important thing about it is that it's very easy to bring to the surface and easy to separate. So the cost should be reasonable enough with the prices of metals today. Of course, we don't know that it's going to happen. So this is an exploration activity. We have taken 5 licenses and 1 license remaining. Once we start the operation, I would think within 2 years' time, we should be able to have a much better estimate of what's available in not maybe the 6 locations, but 3 locations at least. Because it will require a lot of funding and a lot of hard work, but we have put all the elements we think that can bring this project and make Saudi Arabia the first country in the world to produce sulfuric deposit from the Red Sea.
Thank you.
Or any sea for that matter.
I think with this, we conclude our panel. Thank you very much, and thanks all the audience for coming and listening. We hope we give you something different. Minerals from under the oceans. Thank you.
Thank you, panel. That was an excellent way to finish what's been a very dynamic day. And so please give our speakers, our panel, one more round of applause as we ask them to leave the stage and wrap up today's proceedings. So thank you so much. That was a very, very innovative presentation.